Now we're going to learn how to convert from distance or speed or time. So these three essential features here. So I just put a little triangle here for you just to show you a little bit more easily. D is for distance, S is speed, T is time. So I've put it, the reason why I put it into this triangle is because it helps us to convert from one to another and how to utilize the remaining two to get the third one. All three are what we're going to be using. So the first one, to get the average speed, so like kilometers per hour or meters per second, it's always per one unit of measurement. So we always want it for one per 1 hour, per 1 second, or per 1 minute. So that's how we get the average speed. So what we do is we do distance traveled divided by the time taken. So you can see in our triangle, we want speed. It's always D divided by time. So whatever you want, you just exclude that one and just have a look at the triangle. It's D over T. D is on top. So we do D over T, which is distance divided by time. That's the kind of idea. That's how we get speed using the triangle. So that's how the triangle kind of helps. Now the other one is the time taken. Time taken is the distance traveled divided by the average speed. So if you're given the average speed, you can just divide the distance traveled by that speed. So if you have a look on our triangle, guys, the time taken is this one, T. So just don't worry about that one. You see how D is on top again? So we do D divided by S again. Distance divided by the speed. Now the third one is the distance traveled. Average speed times the time taken. So you can see that D is what we want, the distance. So just hide that one and look at the other two. They're right next to each other, so we just multiply it. So speed times time is the distance traveled. So all you really got to remember here, guys, is this triangle, and make sure you remember the order. Make sure D is always on the top, and then we have speed and time. Remember the DST rule. Let's have a look at the questions. If you look at the context of the question, it's quite easy even if you don't have the triangles. But just keep that handy for you just in case you forget. So let's try question 1. A car is traveling a distance of 252 kilometers in 3 hours, 30 minutes. Find its average speed in kilometers per hour. We want the average speed. And if you have a look at our triangle, remember how we have our triangle, DST? The speed one, this is what we want. And look at the other two, it's D over T. So we can say that speed is distance over time. And therefore, distance traveled is 252 kilometers. Time taken is 3 hours and 30 minutes. But because we want it in kilometers per hour, the distance is already in kilometers, so we don't have to do any conversions. But hours, 3 hours and 30 minutes. 30 minutes is half an hour. So we can say it's 3.5. So I've just converted that, 3.5. And then the top is just 252. Just go ahead and divide that, guys. You should get something like this. So it's 72 kilometers per hour. Make sense, guys? That's the answer. And then B, find its average speed in meters per second. Now I've got the speed, but we want to do a bit of conversion to convert it to meters per second. How many meters in a kilometer? There's 1,000. So to convert kilometers to meters, we simply got to multiply by 1,000. But how many seconds in an hour? Well, there's 60 seconds in a minute and 60 minutes in an hour. So it's 60 times 60, which is 3,600. So what I'm going to be doing is to convert to meters, I multiply by 1,000 meters. To get it per 1 second, we divide it by the number of seconds in an hour, which is 3,600. And then just multiply all together, and that's what you should get, meters per second. So here you got to know your measurements and conversions very well. Question 2, determine what is faster, 100 kilometers per hour or 28 meters per second. Now to compare these two, you've got to put them into the same units. What we'll do is we'll convert one or the other. Let's just convert this one to meters per second. How many meters in a kilometer? 1,000. So to convert kilometers to meters, we've got to multiply. How many seconds in an hour? 3,600. So what I'm going to do is multiply 100 by 1,000 to convert to meters. And then because we want it per 1 second, because we want the average speed, we divide it by the number of seconds in the hour. So there's 3,600 seconds in an hour, right? That's why it's like that. And just calculate it, guys. It should be 27.778. And convert the two. This is actually meters per second. So if you convert these two, which one is larger? This one is larger, so we're traveling more within a second. So therefore, 28 meters per second is faster. Question 3, how long does it take to travel 240 kilometers at an average speed of 80 kilometers per hour? Now, we want to know how long it takes, so time. So again, using our little triangle, D, S, and T, we want how long it takes, so it's the time that we want. So if you compare the other two, we can say that time is distance over speed. Make sense? So the distance traveled is 240 and the speed is 80 kilometers an hour. So we divide those two. So distance over speed, so 240 divided by 80. And that should be 3, so 3 hours. Because this is in per hour, isn't it? So that's why it's in hours as well. So make sure you get your units right, because that's also very essential in a question like this. Question 4, convert $12 per hour into cents per minute. $12 per hour, I'll write it like this. Now tell me, how many cents in $12? Well, we just multiply it by 1,200 cents. And how many minutes in an hour? 60 minutes. Yes? So if I want to convert it, because we want the average one, we have to find how much dollars it takes, how much cents actually, it is per 1 minute. So we've got to divide the 12 by 60. But which is in this one, I just wrote 12 divided by 1. But in $12, we know that there's 1,200 cents. And in 1 hour, there's 60 minutes. So I divide it by that one. And then just calculate it as 20 cents per minute. Question 5. Convert 20 milliliters per second into liters per hour. Okay, so again, how many milliliters in a liter? There's 1,000 milliliters in a liter, okay? How many seconds in an hour? You should be very good at this now. It's 3,600. 20 milliliters. If I want to convert that to liters, we know that we're going to divide by 1,000. When we go from a small unit to a large, we divide. It's going to be 0.02 liters. And then, if I want to convert seconds into hours, we know that it's 1 over hour. 1 second is this fraction of an hour. So just remember these conversions, okay? First of all, we have to do 20 meals divided by 1 second because it's 20 meals per second. So to get that average liters per hour, we're going to first divide the two. And then we know that that's this one. So remember how I divided by 1,000 to get that? And I divided by this to get this one, okay? This fraction of an hour in 1 second. Calculate it, guys, and that should be 72 liters per hour. Question 6. A family uses 135 kilowatts of electricity in 90 days. Find the rate of electricity used in watts per day. So we don't want kilowatts per day, we want watts per day. Kilo means 1,000. In 1 kilowatt, there's 1,000 watts. Just remember that. So if I want to convert 135 kilowatts, I've got to multiply by 1,000 to convert to watts. And then we divide it by the period, 90 days. Calculate it, it should be that much watts per day. Okay? Now B, if the electricity costs 1.52 cents per watt, find the total cost in dollar over the 90-day period. It's 1.52 cents per 1 watt, but we have 1,500 watts, so we just multiply it together and get this answer. So this part is what I have is in here, and then I divided by 90, but we wanted to know how much over the 90-day period, so we don't have to divide by 90 in this case. We didn't divide by 90 in this one. So we just left that one because we want to know how much in the 90-day period. And I've also converted this to dollars just for the sake of being more convenient because we don't want to have too many cents, right? So it's roughly this much dollars. Okay, guys? So yeah, make sure you don't multiply by this one because that's per 1 day because we want to multiply it by 90 to get over the 90-day period. So don't forget to do that. Question 7, John types at a rate of 60 words per minute. How long would it take him to type a 1,200 word essay at this rate? If he types 60 words in 1 minute, how many minutes would it take to type this many words? We want to know how many lots of 60 words in 1,200 words. So we just divide it and get that. So it takes 20 minutes. That's all you need to do. Now B, how much longer would it take Jane to type this essay if she types 45 words per minute? Let's use this rate now. It takes 45 words per minute. So this time we want to know how many lots of 45 words are in 1,200 words. So again, we divide it and get that. So it's 26 2/3 minutes. So which one is faster? We want to know the shorter time taken. So the shorter time is obviously the 20 minutes. So therefore, this one is first of all this much. I'll just convert it into the seconds. But even if we don't do that, you can kind of compare the two numbers and see the smaller number. It's this one. So therefore, it takes 6 minutes and 40 seconds longer than John. Because this is the shorter one, we have to subtract the shorter one from the larger one. It would be very, very handy if you do calculate it into minutes and seconds, and that's more convenient for the teacher to look at and just to show that you're good at your conversions. Okay, so that was some conversions between distance, speed, and time, and we've also got some money and this kind of time also incorporated.